Okay, good day to us and welcome to this section. This is part of our healthcare and laboratory safety management program. So today I'm going to be doing like an overview of the entire program of the entire course. We have done some aspect of it. So if you have not, please do well to go to over our previous sections. So today, part of it is at the end of this, we should be able to understand how safety facilities impact on the efficiency and the safety of the laboratory workers and the environment. Describe the general safety program practice and the requirements in the laboratory. They describe hazard identification and risk assessment. They describe the role of facility and safety in implementing quality management systems. So these will help us to wrap up the program for our healthcare and laboratory safety management program. Please, if you can hear me, type on the comment section that you can hear me loud and clear. Okay, thank you. So by also way of introduction of going around it again, which we have known over the previous section, the facility and safety is part of the 12 quality system essentials. So this is 12 quality system essentials. For those of us who don't know, this is it. We have organization, personnel, equipment, purchasing and inventory. We have process management, we have information management, we have document and record, non-conformity event management, assessment, continuous improvement, we have customer focus, and we also have facility and safety. So part of it, what we are doing is facility. So if you want to have a good understanding of the 12 quality system essentials as related to healthcare practice, you can take our basic quality management system course. There you have all this. But you know what we are focusing on this program is our facility and safety management. Okay, thank you. You can hear me. Yes. Okay, you can hear me loud and clear. Please just listen, you hear me. And yes. So, what are some of the risks associated with pre-examination and examination processes? Now, ask yourself, just write it down. What are some of the risks associated with pre-examination and examination process? All the processes within the lab. You know, we have the pre-analytical, analytical, and the post-analytical. So, what are some of the risks that is associated with the pre-examination and the examination processes within the lab? Now, by way of introduction, as part of the QMS implementation, a laboratory needs to facilitate to ensure that the quality of examination and result are safe. There must be safety. Now, as part of a good facility, it helps in the efficacy of the service that is provided. Now, the health of the personnel and the patient and the visitor are also what important. So to achieve this, the laboratory should implement what is called biosafety and biosecurity program. Biosafety and biosecurity program. So you're going to know the difference between biosafety and also biosecurity. So what is biosafety? Now, the laboratory biosafety, this is a containment principle, technology, and practice implemented to prevent unintentional exposure to pathogens and toxins or their unintentional release. That's biosafety. All the principles, all the technology, all the practice we do to implement to prevent unintentional exposure to pathogens, to toxins, or to all their unintentional release is known as what we call laboratory biosafety. Now, on the other hand, biosecurity has to do with protection, control, and accountability of valuable biological materials within the laboratory in order to prevent their unauthorized access, loss, theft, misuse, and diversion or intentional release. I don't know if you get it. Now, so the laboratory safety management, these are all the principles, all the technology, all the practices, the SOPs, the manuals, everything we do to prevent unintentional exposure to pathogens, to anything that can cause safety issues or their unintentional what release. But biosecurity here has to do with protection, control, and accountability of valuable biological materials within the laboratories in order to prevent their unauthorized access, loss of it, theft, misuse, and diversion or intentional release. You know, a lot of bioterrorism has happened and can happen, hereby people will pick up what biological materials and use them for weapons, use them for for things that can cause damage. So those are intentional release. So what we do to authorize those things? So biosafety protect people from dangerous pathogens. Well, biosecurity protect pathogens from dangerous what people. Biosafety protect what? People from dangerous pathogens, while biosecurity protect pathogens from dangerous people. I hope that is clear. So both the biosafety and biosecurity, we have, so biosafety also involve engineering control, example, like the biosafety cabinet and etc. Those are biosafety programs. Now, good laboratory practice, hand wash, spill, cleaning, some of all these things we have enumerated in our previous classes. Use of personal protective equipment, all these are what biosafety programs. When we talk about biosecurity, we talk about password to data, security guard, locked doors, card readers, camera, fences, burglary bars, magnetic locks, biometric fingerprints. All these things help to secure the unauthorized use or unauthorized access to valuable biological substances. There's some things that are common to biosafety and biosecurity, include access control, personnel management, practice SOPs, inventory of biohazard, waste management. We have done waste management already, proper shipping of specimen, and etc. Now, for safety program, it should be based on risk. Every safety program should be based on. So the actual risk of a given scenario is influenced not only by the agent you handle, or by the procedures being performed and the competency of the personnel engaging in that activities. So you need to adopt a risk and evidence-based approach when it comes to what? Biosafety, rather than a prescriptive approach. In other words, risk management will tell us that, okay, before something happens, we have to put in place, identify the potential risk, manage it, and ensure it does not happen. Or what's the risk? If something is happening, what is the risk of it likely going to happen? Is it going to be loud? Is it going to be is it going to be dangerous? Is it going to be severe? Is it going to just be light? So those things form what risk assessment. Now the aim of it is to eliminate exposure to hazard if possible. That's the essence of what safety program. Please, if you can hear me, type on the comment section and you can hear me loud and clear. Okay, when we talk about hazard identification and risk assessment, so biosecurity risk assessment and management process. So first and foremost, when you want to do a biosecurity risk assessment and management process, you identify and prioritize the asset, including inventory, equipment, chemicals, biological and radiological substances. After identifying, you look at the potential threat. What are the potential threats of these biological materials and the vulnerability? Remember, we're talking about biosecurity here. Then you analyze it, you analyze the risk, and put actions to mitigate such potential risk. Now, develop. What do we mean by develop here? It is to develop an overall risk management, including incident management and emergency response. So part of biosecurity risk assessment is you are able to identify, you are able to potentially identify and prioritize those risks. You analyze it, you develop it, and you evaluate it. In other words, you evaluate those actions that are taken to ensure that those things does not happen. In other words, we evaluate the institute risk posture and protection of objective. Now, risk assessment is a very good aspect of safety and biosecurity. Because what we are trying to do in risk assessment, we're trying to look at whether it is biosafety or biosecurity. We're trying to look at what are things we need to put in place. First, we identify it, the potential of harm. Then we analyze it, and at the end of the day, we put in strategies to be able to mitigate what such things. That is what risk assessment is all about. But we know we are not discussing risk assessment yet. So discussing risk assessment is another whole thing. But this is an overview on how you could implement risk assessment in biosafety and biosecurity. What are the examples of hazard? We have biological hazard group, we have chemical hazard, we have physical hazard. All these are different types of what hazard. So we have non-propagative procedures with primary samples. Those are biological hazard. We have things like propagative in vitro what activities. In both in vitro activities, we also have what a hazard, drug resistant samples, aerosols, and etc. Chemical hazard, we have toxic chemicals, oxidizing chemicals, corrosive chemicals. Now, physical hazard could be compressed gases, electrical equipment, radiation, environment, ventilation, indoor air, noise, pressure. All these things forms what physical hazard. Now, whether they are biological hazard, whether they are chemical hazard, whether they are physical hazard, they have the potential to cause what harm. And that is why you need to put in the biosafety measures. Now, one of the biosafety measures we need to put in is to have what a safety manual. Any organization that does not have a safety manual does not have a safety program. So safety manual is key. The safety manual will tell you a whole lot of things that needs to be done within that organization to ensure what safety. Now we're going to come to that aspect. Now, so this is the way to do a risk matrix. A risk matrix. So in risk matrix, we have what we call probability and severity. Probability and what severity. So if something happens, now the ones you see on red is known as high risk. The one on yellow is known as medium risk, and the one on green is known as low risk. Are we communicating? So if you are doing a risk assessment using the risk matrix now, so now the question is, for example, what is the severity if this thing happens? Are you getting me? If it's going to be minor, then it is frequent. That means it's a middle risk. Now, if it is negligible, the severity is going to be negligible. And it happens frequently, that is a high risk. Now, look at the first green we have here. If it's a minor, and is probably not going to happen, probability that it's not going to happen. We have improbably, remotely, occasionally, probably, and frequently. So those are the probability metrics. Why the severity is going to be minor, negligible, marginal, critical, catastrophe. Let's say, for example, if somebody gets electrocuted, what would be the severity of that thing? Is it going to be minor, and negligible, marginal, or critical? So it may be critical. So, but if there is possibility that is going to happen frequently, then when you use the risk matrix, that is going to be what? High risk. I don't know if you are getting the way to use this chart. Okay, if you get it, please type on the comment section that you understand how to use the risk matrix. Okay, yes, okay, thank you. Okay, now someone said I should explain again. So risk matrix. Now, risk matrix is a tool using identifying risk as part of risk management. So if something happens, if something is going to happen, now we have what we call severity link and we have the probability link. Probability is from 1 to 5, as you can see. Improbably, remotely, 3 occasionally, 4 probable, and 5 frequently. That is probability. The probability that this thing is going to happen, this thing we are identifying as potential risk. Then if it happens, Is it going to be minor? Is it going to be negligible? Is it going to be marginal? Is it going to be critical? Is it going to be catastrophic? So if it is negligible and it is frequent, then it is high risk. If it is marginal and it is frequent, it's also a high risk. But if it's going to occur, maybe improbably, that the probability that that is going to occur is improbably, that may not likely occur. And if it happens, it's going to be minor, then it is what known as low risk. Yeah, just a chart. So you look at the boats and you place it. That determines what that you can use that risk matrix to identify the potential of severity. So when we talk about risk, potentially situations of exposure and release, the likelihood of exposure, severity of the consequence to exposure, information gathered influence the likelihood and the consequences of it. How do you mitigate biosafety risk? Now, control of biosafety risk. Please take note of this. Now, we have most effective and least effective. We are talking about how to control for biosafety risk. Now, all you see up is the most effective one. The least one is the least effective one. So, elimination. What does elimination mean? Physically removing the hazard. That is what most effective. So we have elimination, substitution, engineering control, administrative control, and PPE. These are the control of biosafety risk. So substitution means replace the hazard. Now, I'm going to give us an example. Engineering control is isolate people from the hazard. Administrative control protect people from the hazard by changing the way they work. Now, PPE protect people using personal what? Protective equipment. Let's say, for example, now we are talking about during the time of COVID exposure. Now, one of the least way or the least effective way of controlling it is by using PPE, true or false? Now, another way you can use to control that risk is you protect the people from the hazard. So by changing the way they work. So instead of them working together like the way it is, you can now begin to put people in different departments, change the way they work to avoid what if those contamination. That is administrative control. Now, engineering control is like isolate the people from the hazard. Example, you can use things like biosafety cabinet, biosafety 2, biosafety 3. So with that, you have isolated the people from the hazard. Now, the hazard is there, but with that engineering control, with that technology, you have isolated the people from the hazard. Now, substitution means replace the hazard. Whatever that is causing that hazard, you can replace, if you can replace the hazard, that's substitution method, which is more effective. Then elimination is totally removing what that hazard. You could apply it to any exposure, to any potential biosafety risk. So from elimination to PPE, these are the one up are the most effective, the down one are the least effective. So elimination means removing the hazard, not working with the biological agent. That is elimination. Substitution means replacing the hazard with something less dangerous. Example, replacing an aerosol generating procedure with one that does not produce aerosols. That is substitution. The engineering control example like lab design, maintenance, heating, ventilation, air conditioning, use of biosafety cabinets, using equipment to reduce or extract the aerosols and fumes, shelf sheeting needles, safety engineering, medical sharps and sharp containers. All these are part of what engineering control. Use of plastic instead of glass blood collection tubes and what, etc. All these are known as what? Engineering controls. So unsuitable laboratory facility can impact the personnel, the employee, the equipment, the sample, and also the test performance. Because there is no way you're going to talk about laboratory safety without talking about facility. Facility is key. Now, personnel safety, employee competency can affect equipment performance, can affect sample integrity, and can also affect what the performance of the test. Now, just write down. I want to talk about unsuitable facility. Give an example of unsuitable facility, laboratory condition, laboratory setup that you have encountered. So write this down. So you write an example of unsuitable facility, laboratory conditions, or laboratory setup that you have encountered previously. I know some of us have a lot of experiences, a lot of laboratory setup that we have worked that that are unsuitable, from environmental to the design to the spacing to a lot of things and etc. They want to talk about administrative controls, means assigning responsibility and authorities with regards to safety, safety policies, and safety procedures. All those are part of what? Administrative control, immunization programs, designation of containment levels, signages with hazard identified with symbols and pictures. All those are administrative controls. The contamination methods, autoclave, incineration, employee trainings, all these are part of what? Administrative controls. The coordinating safety management program, like day-to-day, like what we are doing, all these are part of administrative control. Safety officers, training of staff in safety, keeping the safety manual up to date, performing periodic safety audit and inspection. These are part of what the duties of the safety officer. To coordinate the safety program on a day-to-day basis. Remember that safety is for every one of us. Training of staff in safety, keep the safety manual up to date. So that's why it's important that you must have a safety manual. Perform periodic safety audits and inspection. Who is responsible for safety? Ultimately, all employees are personally responsible for their own safety at work and for the safety of others. So safety is not for the safety officer, for the lab director, or for anybody. The other administrative controls include, we have safety requirements and guidelines. Producing what safety policies and procedures should be based on local and international requirements for that country where you are. Example like the ISO 15190 is a requirement for safety. I don't know for some of us who don't know much about ISO. Or know ISO means International Organization for Standardization. But ISO 15189 is for medical laboratory competency. ISO 15190 talks about requirements for what? Safety. We have WHO laboratory safety manuals, regulatory documents such as Act of Parliament and international health regulations. I think I have the Nigeria policy on safety. I think I will share that with us, etc. Now, administrative control, I want to talk about safety documentation. This is part of our module 6-7. Talk about safety culture, about safety policy, assigning roles and responsibility, risk assessment, safety manual, supporting programs and plan, report and review. All this safety documentation has to be in place. First, safety policy, safety manual, SOPs on biosafety, different biosafety procedures, how to decontaminate, how to use all the biosafety, how to use fire extinguisher, all the safety program that is run in that lab. You must have a safety manual and SOPs, programs, trainings, documentation. Now, what is safety manual? Safety manual shall be readily available for all employees. All employees. So it's not for one person to put it in his or her office. Now, the manual shall be reviewed and updated at least annually. Layout of the rules of the lab, designated responsibilities, describe the compliance with the regulation, whether local or internationally. It must fulfill the requirement of the ISO 15190 of Chapter 1.1.4. And it must be customized to the lab. So you don't just go and copy a safety manual, because it may not be applicable to you. So it must be customized what? To suit in what? Laboratory. So now look at it. What should be the content of what? A safety manual. Look at the screen very well. We have safety policy. Policy describe what you do, what you intend to do. We have fire prevention. So you must have a fire prevention. How do you prevent fire? Electrical safety, chemical safety, radiation, biological hazard. So go back to some of those classes. You see that we discuss a lot of this in fire safety, electrical safety, chemical safety, radiation, biological hazard. your hazardous waste or your waste segregation, how you manage it, you have to put it there in the safety man. Minimal content. It can be more than this. Evacuation procedures, incident protocols, SDS on all material safety and data sheet. We call it safety and data sheet for on all chemicals and agents used in the lab. You must have the other external safety what documents. Maybe your state, your country safety procedures, maybe WHO, all these forms under what other safety documents. So your personal protective equipment, PPE, these head covers, goggles, face masks, face shield, gowns, aprons, gloves, boots. Now we have said it in our previous session. You don't work with your bare hands. You have to put in your PPE. Some of us or some bad laboratory practice or bad clinical laboratory practice see people carrying samples with their bare hands. Instead, you hear all manners of things. It's not today. You know, when we do this, we breach safety procedures. Not only that, we do it not because we are afraid. You have to be afraid because everything, every sample is a potential hazard. It is not as a result of fear, but as a result of being safety conscious. So I have never carried a sample with my bare hands without a glove. Someone will say, oh, if we don't have glove, what do we do? Is it that we should not work? You shouldn't work without your PPE, or else you expose yourself. At the end of the day, you can take some of this exposure to even your family, your loved ones, your friends, and etc. So you have to work with the required personal protective equipment. This is minimal. Are we communicating? If you can hear me loud and clear, please type on the comment section. You can hear me? Okay. And you can see the slide too. Can you see the slide? Okay, thank you. So what is wrong with this image and which PPE should be used? Type on the comment section. What do you think is wrong with this image? What is wrong with this image and which PPE should be used? Okay. Someone say no glove. Use of hand gloves. Okay, is that all? Look at it very well. Can't you see? Can't you see all that things? Needle was not capped, yes. Okay. Okay. The needle was not capped. Okay. The sample was not covered. Spillage can occur. Yes. So these are many more what is actually wrong and which PPE should be used here. Talk about the hand gloves. Okay, moving to the next. When we want to review risks to monitor effectiveness of the controls, there's what to know that the PDCA circle is known as the Denwins circle. It's used for quality improvement. If you're a quality improvement specialist, these are some of the things you do. We have what called the PDCA circle. So for the risk assessment not to be static, you can use the PDCA concept to improve. So it's an improvement tool. That's why if you are here, you have not done quality management system course, you are missing a whole lot. because what you are doing now is just a module, one out of over 18 modules. So it will help you to have a better understanding about a lot of processes improvements. So what will this PDCA circle all about? So it starts to do with plan, do, check, and act concept. So define the frequency of the review of the risk and define the people to do the review. So you plan it, you take action, you check to see that procedure or that program that you have put in place, how active it is, how effective it is. Then you can act on it, either to improve on it or to continuous plan. You do so. You plan, you identify the risk, you plan, you put actions, strategic actions, what to do, document them. A good plan must contain an action, who is to execute the action, the timeline, start date, end date, the resources that is needed, and it has to be documented. Though that is a good characteristic of any plan. Then after you have planned, you do is to take action, because no matter how beautiful the plan is, if you don't act, if you don't do, if you don't take action on it, definitely you are not going to see results. So the doing part of it is one of the most interesting part of what any process was improvement. Then you check to see the effectiveness. At the end of the day, you act on what you have checked. Okay, let's look at 5 pillars about security risk mitigation. 1, we talk about physical security. 2, personnel security. Number 3, we talk about material control and accountability. Number 4, transport security. And number 5, information security. These are the 5 pillars of biosecurity risk mitigation. Biosecurity. So now, when we talk about physical security is a combination of measures used to protect laboratories and their assets from physical what? Intrusion. You can see all these are barriers. You see barbed wire, keys. These are part of our physical security. Number 2, personnel security. In this context of biosecurity, the policies and the procedure used to ensure that only individuals are given the access to sensitive biological material should have that access. If you are not authorized to have access to that sensitive material, you should not. That's what we call personnel security. So not everyone should have access to what? Sensitive biological what? Material. Number 3, we have materials control and accountability. Every materials must be accountable for what assets exist in the lab. Where are they located? Who is responsible for them? Control and what? Accountability. Now, what material and information should we keep track of? We're talking about accountability and control. What are the materials and information should we keep? You should keep the agent. What is the agent that are available? The quantity, the form, the detail, the scope of all those things has to be what? Those information has to be kept. So that at the end of the day, if there's any intruder, if there's anyone who picks it up, if there's any theft, any loss, you can be able to what? Track it. But if you don't keep all this information, you won't know when they are missing. Are we communicating? Number 4, we'll talk about transport security. Transport security is the protection of biological materials when they are transported outside the laboratory areas. So there's what we call triple packaging in sample management. All those things are part of sample management. Some triple packaging, how to package effective. You can read about that. At least write it down. Read about triple packaging. It's the process for packaging hazardous materials in sample management. Number 5 talks about information security. This is the protection of sensitive, valuable information from theft or diversion. It will be on the software or physically, whatever information. Information security is the protection of sensitive and valuable information from theft or diversion. What are the elements of a comprehensive safety program? This takes us to the module 10. element of a comprehensive safety program. Please look at it. For you to have a comprehensive safety program in your facility, you must have hazard identification and risk assessment. How do you identify hazard and risk assessment? So you see that safety and biosecurity is a big deal. And you could even specialize on it. You could be an expert in it. So don't just do this training and say, oh, you have arrived. This is just to introduce you into a whole lot of things. And as you keep going, keep learning, keep improving, definitely you become an expert in it. A lot of people are making big earnings, big living from biosafety and biosecurity. So I welcome you on board. Nothing becomes interesting until you take interest or until you pick interest. So things will become interesting when you begin to pick interest. And your interest will determine your pursuit. If you have interest in something, you want to know about it, you want to learn about it, you want to do more about it, you want to act about it, you want to seek information, you want to build capacity in it. So other aspects of a comprehensive safety program include having biosafety and biosecurity hazard, including blood-borne pathogens and respiratory protection, chemical hazard, physical hazard, emergency preparedness and response. What is your emergency preparedness response? Both policies and programs that is put in place. Preparedness. Talks emergency preparedness and response means when there's an emergency, it could be emergency within the hospital, within the lab, or there's a global emergency. How do you prepare? What is your plan? What will be your response? What are the contingency plans? What are the safety measures? Fire prevention and safety, radiation safety, laboratory ergonomics, equipment safety. Key, personnel work practice, personnel protective equipment, PPE, transportation consideration for samples and hazardous work materials, waste management, housekeeping practice. There are some people, if you see their workspace is looking as if cat and dog or rat, they are fighting. That's why if you go to, I think we'll talk about Module 4, we'll talk about the 5X. How many of you remember the 5X? If you remember what the 5X stands for, please type it on the comment section. Yes. Salt, yes. What are the other 5X? Yes. Okay. Shine, yes. Standardize, sustain. Yeah, that is the 5X. Clap for yourself. So we have sort, set in order, shine, standardize, and sustain. When everything has a place, everything will be in place. When everything has a place, everything will be in place. So have a place for everything so that everything can be in place. So that's what the 5S principle is talking about. Salt, you set in order, you shine, you standardize, and you sustain. Okay, we'll talk about incident, injury, accident, and occupational illness, safety education, and training. So there should be record keeping, safety audit. There should be periodic safety audit. All these forms what a comprehensive safety program. So if there's anyone you don't understand here, please type on the comment section. I'm going to explain to you which of these safety programs you don't understand what it's all about. Waiting, type on the comment section and I will explain. I'll give you 1 minute to do that. Okay, someone said I should explain safety audit. Okay. Any other one? So when we talk about a safety audit, it talks about auditing the safety program. So first, you need to have a safety. You need to be trained as an auditor. You need to have an adequate knowledge on the safety program. Then you need to have a safety checklist. Then you need to have a program, a schedule. You need to have a policy on safety. And you need to have what? SOPs on how to conduct the safety. Because if you do a safety audit, for you to do an audit, you must be trained as an auditor, a safety auditor or an auditor that have knowledge in the areas of safety. So if you do a safety, if you do an audit, you are not trained, you have not been trained or deemed competent as an auditor, then it will not be valid, it's a non-conformity. And if doing an assessment, there's no safety, there's no audit in your facility, a lot of facility will go for QMS implementation. At the end of the day, we see that audit and assessment is zero because they don't have an understanding that they have to do an audit. So you need to do an audit. So let's say, for example, that safety checklist, I'm going to send you like a checklist, yes, on safety. So you look at them, is this in place? You tick yes or no, not available. At the end of the day, they bring out the non-conformities, the gaps, and that safety audit, they will use that gaps and non-conformity to do a corrective action. And part of the corrective action, they will do a root cause analysis and put a corrective action and check the corrective action to see if it's effective. All this is just related to only the safety aspect. That's why I call it safety audit. Any other one? Is that well understood for the person who asks about safety audit? Okay, thank you. I also have programs on if you want to become a safety, if you want to become an auditor. But for us to become an auditor, you have to understand quality management system. You have to understand that it's 15189 before we admit you to become in the safety and the audit or as an auditor. Okay, next slide. So facility and safety are important component of what? A quality management system. Facility design and safety practice should be based on risks associated with the laboratory activities. Laboratories should implement safety and biosecurity requirements based on local and international requirements. Okay. Commitment by top management and a focus on continual improvement is key to establishing and implementing a successful biorisk management system. Laboratories should continuously monitor the biosafety and biosecurity aspect to ensure that the safety of personnel, the client, the customers, and the environment is being put into what consideration. Please hold on. Okay, we have biosafety level 1, biosafety level 2, biosafety level 3, and we have explained that in our previous section. Just hold on, then. So part of the document I'm going to share with you is the Laboratory Biosafety Manual, WHO Biosafety Manual. I think I have the third edition. Oh,